It is the year 4026. A team of future archaeologists is carefully excavating a hyper-sterile ruin in what used to be Taiwan, and they are puzzled by what they are looking at. They find evidence of a facility that cost tens of billions of dollars to construct. They trace remnants of global supply chains that transported ultra-pure materials, all utilized to etch precise geometries down to the nanometer scale. We know exactly what this ruin is, because we dedicate the GDP of small nations to build these foundries today. We do it to serve opaque entities we call neural networks. We understand the basic calculus of these networks, but once data enters, the mechanical process generating the outputs remains opaque. Yet we pour capital and specialized labor into this void, assuming enough power will grant us artificial general intelligence. Dedicating staggering resources to an entity we cannot fully comprehend constitutes a modern chip foundry serves as the 21st century equivalent of an Egyptian pyramid. The pharaohs relied on a hierarchy of priests, scribes, and master craftsmen to interpret the highly complex, cryptic demands of their deities. Look at an AI lab today, and you see a similar structure. Product managers and engineers act as the new priesthood, interpreting cryptic algorithmic outputs like loss functions and translating them into physical silicon architectures. Ancient Egyptian theology operated without a feedback loop. The gods never sent back a message confirming that a pyramid successfully transported a pharaoh's soul to the afterlife. Our digital deities are equally silent. When a language model hallucinates fake facts or produces nonsense, it rarely provides a clear mechanical explanation for its failure. When the ancient Egyptians failed to secure obvious divine favor, they didn't pause to reconsider their core theology. They simply organized thousands of workers and built a much larger stone monument. When our models fail to demonstrate true understanding, we respond identically. We don't discard the core neural network architecture. We add 50 billion more parameters. When dealing with the unknown, humanity reliably equates monumental scale with a higher probability of success. We assume sheer size will eventually solve the mystery. Despite centuries of accumulated engineering knowledge, Egyptian architects displayed intense design conservatism. They learned how to cut stone better and align perfectly with the stars, but they strictly maintained the triangular pyramid shape. Contemporary AI chips possess that same rigid orthodoxy. Despite incredible leaps in computational power, they remain massive, tightly packed arrays of parallel processors. If an incomprehensible power seems satisfied with your current offering, you don't risk a failure by trying something completely new. So, innovation in both fields is restricted. We apply our genius to make the existing structure atomic in its precision, but the foundational blueprint stays the same. This shared persistence across millennia shows that when faced with deep uncertainty, human beings use geometric repetition as a psychological defense mechanism. No pharaoh has ever returned from the celestial realm to report on their burial arrangements, and right now, we have zero definitive proof that scaling up server farms will eventually yield true machine consciousness. If neither of these massive undertakings actually achieves its stated goal, are we looking at history's most expensive misallocations of capital? The answer lies in technological spillovers. The sheer logistical nightmare of stacking millions of limestone blocks forced the Egyptians to invent advanced surveying techniques and sophisticated mathematics. Even mummification, an attempt to preserve bodies for the gods, accidentally advanced medical healthcare for the living. The blind pursuit of a better AI accelerator is doing the same thing right now. Pushing semiconductor foundries to their physical limits has forced advancements in material science and precision manufacturing that would have taken decades otherwise. Computational techniques originally designed to train neural networks on trivial tasks like sorting photos of cats have vastly improved critical fields like medical imaging. Ultimately, it doesn't matter if our silicon gods ever answer our prayers or achieve the consciousness we attribute to them. The mystery is the mechanism. In our drive to satisfy the incomprehensible, we force ourselves to exceed our own capabilities, consistently building the very technologies needed to push human civilization forward.